All right, good. We got it back. Okay, so this is the continuation. The last video had an issue. So we're looking at 2b. We're comparing the y-intercept, guys, for f of x and g of x. Now, the f of x had it in y equals mx plus b form, which gave me the slope right off the bat. It gave me the y-intercept right off the bat, actually, for this one. Because I know that b is 8. b is 8. Okay. We know that for f of x. Now, for g of x, we need to look at this, and we need to really focus on finding the components of our y equals mx plus b form. So I can just point just like I did over here. I can say, well, b is this, okay? So what I'm going to do is I need to find first the slope. That's number one. First, I find the slope. Then I'm going to plug in an x and a y value. That's going to be number two. Okay, we're going to do first find the slope and then plug in an x and y to have b left over. So what we need to do is we need to look at the slope for this is going to be y2 minus y1, x2 minus x1. Okay. Now let's see. I'm going to take these 2 points just because they're both positive. It might be a little easier. Let's see. x1, y1, x2, y2. Let's plug them in. 12 x or y2 minus y1, 10. x2 is 6 minus x1 is 3. You see? I'm using the points that they give me in the table because I know that they represent what's happening in g of x. They represent what's happening. So now all I need to do is 12 minus 10 is 2. 6 minus 3 is 2/3. So I got my slope. Now I can go in here and I can plug in y is equal to 2/3 x plus b. And I'm getting closer. Because now what I need to do is plug in, like I said up here, step 2 is going to be plug in an x and a y value. Plug in an x and a y value, which will allow me to find what my y-intercept is. So first I found the slope. I put it into the equation for for g of x, right? And now what I need to do is plug in an x, plug in a y. How about we use this one? And there's a reason why we want to use this one, actually. We're going to plug in x and y right there. The reason I'm going to pick this is look what happens with x. When x is 3, 2/3 is going to multiply with that really nice. Y is 10. 2/3 times 3 plus b. The reason I picked that is because I had some foresight that 3 divided by 3 is going to cancel out. 10 is equal to 2 plus b minus 2 minus 2. b is 8. All right, so look, my final equation for this is 2/3 x plus b. I've already plus 8. And what I just figured out was that my b value is 8. Now look, let's compare our b values. Our y-intercept, same for f of x and g of x. It's the same. They're both plus 8. They're both plus 8. So that's how I'm going to approach that problem. For 2b, just looking at and seeing what we did, we were given for function f of x the equation so we could find the y-intercept by just knowing where things fit into our equation. We're given a table for the second one, so I found the slope to be able to plug in the slope to my y equals mx plus b. Then I plugged in a point, I worked it out, I found my b. I put it in this equation, but really I just needed to find my b, and now I can compare them and say they're the same. All right. So I'll give you a moment. Go ahead and screenshot that. This is 2b. Screenshot it. The main thing we were trying to do is compare our y-intercepts. How did I get this? Right here. Well, I'll explain it again. So, everyone okay with this one? Yeah, Calvin, you're good. So, with this one, Remember, I found the slope just to put the slope in there. Then I have to choose a point from my table to plug in x and y. So I plug in x is 3 and y is 10. If this x is 3, right, and we have the slope of 2 over 3, the reason why I can end up with 10 is equal to 2 plus b is because 2/3 times 3. 2/3, 2 times 3 divided by 3. 3 over 3 we can cancel out because 3 over 3 is 1. What's left over in that is, right, the 3's gone. So it's b, 10 is equal to 2 plus b. Now I subtract 2's and I get my b is 8. Now I just figured it out. Excellent, good question. All right, let's keep going, don't stop. All right, let's see. Okay. Okay, so for 5b, the second 5 in our set, the last ones here, we are told to compare rate of change for f of x and g of x. Okay, we have to compare the rate of change. F of x, they give it. Oh, the rate of change over interval, the interval of 0 and 4. Now I'm going to keep that there for a second, but this is basically, these are, the interval is our x values. So this is the lower and this is the upper. Okay. F of x, we're told is 1 plus 0.35 over 4 to the 4x. Okay. This is the hardest problem, guys. The graph they give us has, let's see, this is at 70. Has one point on the y-axis at 70, or y-intercept. Okay. Okay, go to classwork, go to the assignment, unit 2 review, click on the link, and that's what I'm looking at. These problems are not for you just to take screenshots and put it into a document and turn it in. These are going over the problems that you have to do and write it all out just like a regular assignment. This is basically just going over the homework assignment that you guys have due on Friday, because this is for the test, okay? All right, hope that helped. Let's see, we're also going to be looking at what's happening at 4. So 2, 4, because it's 0 to 4, 0 to 4, okay? This is 0.35 divided by 4. That does kind of look like a 7. Now it looks more like a 3. Okay? You guys can see these problems if you have it open as well. So click on that link in the classwork and you'll have it open. You'll be able to copy it down faster because you'll see it as well. All right, now I know that I'm just looking between 0 and 4 for my x values. So I'm going to put 0, I'm going to put 4. A lot more is happening out here, but I don't really care. I don't really care what's happening in the graph there. So g of x is this graph, and at 4, it looks like we're at 80. Whoops. Okay. So here's our function. It goes like that. Okay. Now look, what this is saying is my lower x value is right here at 0. Okay. That's my lower. My upper x value is at 4. Okay. So, yeah, I know. I'm lagging. I know why. Let me turn this one part off. I'll deal with this later. Okay, I know I might be lagging, guys. we'll just do our best, okay? So look, what this is saying is the rate of change is really just our slope. Just our slope. So when I'm looking at a graph and they give you the lower and the upper limit, what I'm trying to find is I look at the point that is at that x value of 0 and that x value of 4. And what I'm going to do is just make a line between them. We're just looking for the slope of that line. What is the slope of that line? Now, we can find those points. We could do all this work. But really, all I need to do is remember that slope is the rise over the run, right? So what is the rise if I go from 70 to 80? Plus 10, right? I'm just looking to see what is the slope between this point and this point. X is 0 and x is 4. Okay? And then look, I need to go to the right. How far to the right do I go? From 0 to 4? I go, well, look, it's plus 10. That's going to be plus 4. So it's 10 over 4. And what does that give us? 2.5. Is everyone okay with that? You see what I did there with the graph? All you have to do is look at the interval. The interval tells you your x values for the lower and the upper interval boundary. So the lower, it's like we cropped the photo. We're just looking between these two lines. So all I had to do is look, I'm at 70 for 0. I looked on the graph closely. I found that value. At 4, I'm over here at 80. So I had to go up 10 over 4, 10 over 4, rise over run. Up 10 over 4, positive 2.5. That's my slope. Now let's look over here. Because over here, we just have a function. We just have a function, and what I know from this function is I know that if I could find the y value that works with our lower x, so this is x and y. If I find the y value, and I look at my upper limit and find the y value when x is 4, find my upper limit, y value, then I could plug into the slope formula and find the slope. That's going to be our approach. So this looks like it's going to be a lot of work, but actually plugging in 0 to this exponent is not going to be bad. What I'm going to do is first, I'm going to simplify what's in that parenthesis. So I'm going to do 0.35 divided by 4 and add 1 to it. And now I can rewrite this a little bit easier. 50 times 1.0875 to the 4x. Okay, so now we're going to be able to plug in x values are 0, work it out, find the y value. Plug in 4, work it out, find the y value. And then we're going to just plug into here. So there's not going to be like, oh, you just do this, then you just do this, then you just do this. You really got to think about, well, what are they asking? What am I going to need to find to compare these two? And how do I find it? We know we're dealing with trying to find the slope. So if I know I'm looking for the slope, I know that for this function, I'll need to use my slope formula. But what do I need first? I need 2 points to plug into my slope formula. So that's where, given the interval 0, 4, we plug in 0 for x, we get a y, plug in 4 for x, get a y, throw it in here, we're done. Okay. So let's see. F of 0, 50 times 1.0875 to the 4 times 0. 4 times 0 is 0. Anything to the 0 power is what? Anything to the 0 power is what? Nope. Anything to the 0 power is what? It's a weird one. It's a weird one. There it is. Thank you to the one person. Anything to the 0 power is 1. Is 1. Thank you, Jatavia Ava. Perfect. So I know that all of this, the parenthesis, all of that is going to be equal to 1. And what is 50 times 1? 50. I found 1 point. Awesome. Found 1 point. Now, the next one, we need to plug in 4 for x. F of 4. Watch, 50 times 1.0875. 4 to the 4 times 4. That's going to be our power. This one's going to be big, I think. Let's see. Maybe not. 50 times 1.0875 to the 16th power. Remember, you're going to have to do some calculator work. So if you're like, I hope I know how to do that. Nah, calculator work is like, I hope at this point getting second nature plugging in exponents. Let's see. 1.0875. Right? Raised to the power. You see this function here, this button? I'm going to push it. And then we're raising it to the 16th power. Let's see. That didn't break my calculator. Awesome. All right, so 3.8271 or so. And so that, what I just did was 1.0875 to the 16th power. Now we got to multiply that by 50. All right. I'm going to go ahead and take 191.4. We won't be able to graph that. It's going to be really minor as far as that goes. If you would have taken 191, I would have taken that. That would have been fine. All right, look. X sub 1, Y sub 1, X sub 2, Y sub 2. Let's plug them in. 191.4 minus 50. 4 minus 0. I like that. 4 minus 0 is the easiest problem. 191.4 minus 50 is 141.4, and then 4 minus 0 is 4. So what are we going to get? Divide that by 4. 35.35. I like that. All right. So guess what we are going to say here? This is f of x. This is g of x. Right? If your computer's lagging, maybe turn off any other programs, any other streaming in the background, anything. Just turn everything else off. Is anyone else unable to hear me? Okay. Sounds like it's a... Yeah, people say they can hear fine. So, I don't know. I think it's turn everything else off. Okay. So look, we need to compare these now. F of x has a greater slope, rate of change, than g of x. Some to that extent. The answers may be written slightly different, but look, this is going up faster. It goes up 35.35 for every 1 unit. This goes up 2.5 for every 1 unit. Okay, so that's a big deal. That's a big problem. Yeah, it is lagging sometimes. I think it's because I'm recording a video and sharing all this. Sometimes that happens. I might have to run a hard line, actually. Well, actually, I don't need to anymore, because now from here on out, it's just test time. All right, so that's number 5B. I'm gonna let you go ahead and take a screenshot. Let me make it a little darker so you can see it. All right, take a screenshot in 3, 2, 2, 2, 1, 1, 1. Screenshot. Okay, I'm actually glad we got to go over these problems here. Let's see, the last problem, number 6, is another comparing the 2 forms. So I'll go ahead and, well, since we have 1 minute left, I won't start that. So I'm gonna stop this video. I'll link them all together, guys. So I'm gonna try to pause it. Let's see if